All right, guys, we're on our last example of a standard form parabola. This will also be our last type of x-intercepts. Remember, the whole beginning part of these is all the same. The only thing that changes a little bit is what our x-intercepts look like. You can do the second example on the same worksheet that you did the first example from today, right? So remember, there were two spaces. So here's our second example that you can write in the second space. This example says y equals negative x squared minus 6x minus 9. As always, we'll start with our axis of symmetry. In this problem, my b is negative 6. So when I plug that in, it'll change to a positive 6. And my a is negative 1. So make sure you plug in a negative 1 for your a. And then this simplifies to x equals negative 3. And then remember, you can always start graphing right now if you want to. So go to the negative 3 on the x, put a nice dotted vertical line. Next, we take the negative 3 and we plug it into all of the x's in the original problem. Now, this one can get a little bit confusing. So we have the negative on the outside, and we also have a negative 3 on the inside. And then if you're using a calculator, just type it in exactly how it looks. Don't do any simplifying first. Type it in exactly how it looks. If you're not using a calculator, remember that the order of operations says that you have to do this negative 3 squared first. And then technically, this is a negative 1 on the outside. So you'll do negative 3 squared, which will get you positive 9. And then that positive 9 is going to multiply with this negative 1 on the outside, and it's going to go back to a negative 9. I just want to clarify that it's not negative 3 squared is negative 9. Negative 3 squared is positive 9, but that negative sign that was in front changes it to a negative. Okay, and for this problem, my y-coordinate of my vertex is 0. So my ordered pair is negative 3, 0. And if you want to graph that right now, you can graph it right now. And look where that dot is, guys. We'll talk about that a little bit later. Okay, I now have 4 answers really quickly. I need to first notice that my a is a negative number. It's negative 1. That means this is opening down, which means it has a highest point or a maximum. My domain is always all real numbers. And then for the range, since it's opening down, I'm going to do less than or equal to, and I'm going to use this number 0 for my vertex. Next is my y-intercept, which is just my number c, which is negative 9. So 0, negative 9. And we could actually do the x-intercept right now, but I'm so used to doing it after we're graphing that we'll wait a second. But we already drew the x-intercept. What's the vertex? All right, our special ordered pairs are going to change a teeny tiny little bit, right? So our a in this problem was negative 1. So I am going to have to multiply all of the y-coordinates by a negative 1. And so it's not going to change the numbers, but it will change them all to negatives. And so basically what that does is it helps us remember that this parabola is opening down. So instead of going over 1 and up 1, I'm going to go over 1 and down 1 from my vertex. Over 1, down 1, and reflect. Instead of going 2, 4, we'll go 2, negative 4. Okay, so over 2 and down 4. And then again, you guys can fit the next one on your graph. And this is where you're going to get your y-intercept. Okay, so from here, you're going to go over 3 and down 9. And that should get you to this negative 9 on the y-axis. Okay, and I have a nice downward facing parabola. Now, this one, we actually found our x-intercept super early, and you could have written it down as soon as you figured it out. But my vertex is actually the x-intercept. And in this problem, there's only one point that touches the x-axis. So there's only going to be one x-intercept. If this was our last chapter before winter break, this would be when we got a double root, right? When we got the same answer twice. So when the vertex is on the x-axis, that's the same thing as a double root. This concludes all of our standard form examples.